Okay. Hi everyone. Let's wait for some people to come online and then we shall get this going. Gaia Ochos, and I think this is. I'm looking for Zephyr. No, I know my screen is visible, but I hope it is. Hi everyone. And we're live. Okay, cool. So we have a version of Zephyr here that has a branch. There's this branch, IMX219 UVC. This is what I'm working on right now. I'll add this to the I'll add this to the code. So I mean to the description, so that so that everyone can get a link to it. Hey Bartholomew. Yeah, it's good to see you, man. It's been a while. I'm glad to be doing some Zephyr too. It's been a while. I just went through the streams and I realized I did like a whole week of RTL and I never did any Zephyr stuff this week. I think, well, it's because I was working on Zephyr at work so much, so I didn't and because it mixes up. Anyways, so Zephyr, let's do this. Zephyr 4.2.0. One of the bigger features for Zephyr 4.2.0 was that UVC came with USB video class driver came to Zephyr, and I kind of want to try this. I want to try this so that we can. Actually, I want to try this because I want to run images through my microcontroller and do some image processing with them, and also, kind of learn some stuff and see some stuff. And also, I've been very scared of USB for quite a while. I think I'm gonna get hot. I didn't realize it was gonna be this thing. Okay, cool. So I've been scared of USB for quite a while, and yeah, so this is a perfect way of getting in, and as it turns out, we have to debug USB stuff, so that's life. Life works out that way. So let's actually just quickly do an experiment, quickly get something running, and then once we get things running, we can go back and see if we can make the stuff work. I think the first thing I want to do is I want to end, where's this? Okay, cool. Let's just go into Zephyr. As I've shown, I'm on a custom branch that combines two PRs. The PR to bring in the IMX219 camera and the PR to bring in DCMIPP onto USB, DCMIPP on the STM32N6, NUCLEO N6. Those are two. That's the code that I'm running on right now. It's just one of the PRs merge on the other, and I have a little branch pulled out. But the first thing I want to do is I want to go into samples, and I think I might need to modify the code there because I was doing some experiments yesterday. So let's go into samples, and let's go into subsys. Let's go into USB. Let's go into USB, and then we want to go into UVC, and in here I just want to do some stuff in the app overlay that we're going to come back to. The first thing I want to do is remove the chosen. Once I remove the chosen, I should be able to just not be able to just do this. We'll come back to this later. Just now, we'll come back to this, but let's do an experiment first to establish what we need first, and then we go to that. So cool. Clear. So what we want to do is to do something like this here. Why do I have the very log thing open? I swear I can like shut down my machine and like I still have stuff open. Let me just close some stuff. So it's easier, so it's easier to navigate between stuff. That's open. I don't need that. That's email open. Okay, cool. So let's do this. Where's build? And I think I need the S video SW generator. Let's build that. I do have a build folder, build something somewhere here. So I'm building for the, I'm building for the UVC, and I want to use the shield. I want to use the software generator shield. We'll look at what that is right now as we SW video generator. So on my old machine, builds take a little bit. Oh yeah, where am I? Oh yeah, so this code wants to be outside. This code wants to run. Okay, cool. I'll just run it from outside and it's okay. So I can keep the branch, so I can keep them at command. Okay, so while it builds, let's go and look at what this other thing is. So this is a video snippet, and this snippet allows, basically builds, sorry, there's a fly on my desk. Got it. Okay, so this snippet allows us to basically make an emulation of software on the hardware that we're using, and we're going to start with that. We're going to start with that, and then once we get that running, we're going to start moving towards hardware. So this is kind of the setup we're going to be running today. That's an NUCLEO N6, and this is an IMX219 camera with a CSI cable on it, and that's connected to the CSI port on the NUCLEO N6. And then we have like, this is MCU USB, and this is debugging USB. That's really it. Let's see what we can do today. So, is that finished building? Oh, I did something wrong. Video SW generator. Okay, cool. So that's fine. So I built. I chose the wrong thing. Video SW generator. Yeah, that's what we want. So cool. Let's see. Any questions so far? 5 minutes in. Does anyone have any questions? It's really good. If anyone has any questions. While we're building, anyways. Yeah. Whenever there's builds, people can ask questions. So if you have a question, rush to put it in during building. And say hi on the chat if you're around. So let's leave this. Oh yeah, I had modified the code a bit. So this is going to be a problem. I had modified the code a bit. I'm sorry if this is not exactly when we start this debug. I did do a bit of it yesterday, but it's fine. We can start from afresh and get everything going. So this, whatever we're running right now, isn't going to run because most of this code is commented out. So, and then I need to get rid of that. Yeah, cool. Sorry, let me build again. I apologize. Let me build again. West build NUCLEO N6 snippet video SW generator, Zephyr samples, USB samples. So cool. Let's build that. Yeah, if you're online, say hi. The description has a link to our Discord community. You can join us there and learn some stuff. We all just do stuff together. We experiment and we learn together and we build stuff. So feel free to join the Discord, feel free to say hi. And yeah, that's a really good thing. So let's build this. Yeah, that's the thing. Anyone, any questions? Any questions so far? Any questions? Any questions so far? No questions. Hey Bartholomew, is your overlay working for the NRF 54? Maybe it's not here, but I always assume Bartholomew is here, so sorry about that. Maybe it's not here, but there's a few of you here. Whoever's here, just say hi, please. please say hi. I can see that you're here, but I don't know who you are. Everyone's too shy. Maybe it's some competitor and they're trying to steal the stream. Okay, cool. So this is the other thing about the NUCLEO N6. This is almost like the. Oh, amazing! You can collect samples from the from the microphone. Nice, Bartholomew. Where's flash? I'm gonna flash that. It's gonna go through, and then once it's done, I'm gonna pull it out, and then I'm gonna put it in. Well, I'm always on even when the stream is off. Bartholomew is always on even when the stream is off. Thank you, Bartholomew. Okay, cool. So let's do a refresh there, and let's run an ACM0 here. Amazing. So we have a snippet. The UVC sample is running. So we have UVC, USB video, USB over video, we have it. So I think the next thing we need to do is waiting for the host to select video. How does the host select video? Let's go see that. Cool, let's go see that. So the way the host selects video is you do something ls USB. Sorry. Let's wait for it to come back. It's gonna come back, don't worry about it. Sorry, somehow OBS crashed and somehow I lost connection. I'm back now. Bartholomew, am I back? Please let me know. It says excellent connection. So I'm doing something that ends up making OBS crash. I'll try and monitor that it doesn't. Thank you, Bartholomew. Where did it die? Where did it die so that I go back there? So I think before the thing went away, I was explaining what DCMI is, which is a digital camera interface from SD. That is why DCMI. That is what DCMI is. But with the newer ones, we have DCMIPP, and DCMIPP is up. Let's look at the datasheet. I like datasheets more and reference manuals. So let's look at here. Let's look at just a moment. Let me know if this thing dies. STM32 N6 ref manual. So page with DMX and LSUSB. Oh, okay, cool. Sorry about that. Let's go back to that again. Okay, cool. So this is where Bartholomew says it went off here. So here we go. LSUSB. We now see a Nordic semiconductor UVC sample. This is obviously just because it's a sample, it's using the code that is there. So with this UVC sample, we should be able to use the guide here and play some video from our microcontroller. So let's try that. ffplay -i dev video 2. ffplay. Yeah, there you go. This is video from our STM32 N6. However, right now, as you saw previously, we built using the software video generator. This is a snippet for software video generation. So this is just, it's sending us some generated frames to the device. That's what it's doing right now. What we want to actually do is convert all of that to run off of this IMX219 camera that I have connected to the CSI connector. And in order to do this, we need to combine existing work from 2 branches. There's 2 current open branches on Zephyr, or rather open PRs. There's a PR that gets in the driver for the there's a PR that gets the driver that adds the driver for the IMX219, which is the Raspberry Pi camera V2. This is the module. It's the same one that's connected to the STM32. Cool. And then we also have a camera interface driver PR from for the STM32N6, the board that I'm using, that I keep showing, that is on the video for this. So the thing I did was I checked out this PR over here, this driver's PR, and I checked out the camera driver PR and the camera interface PR. I checked those two out, and they're on my device, so I'll show them to you. CD Zephyr, and then clear, and then I also git branch. So as you can see, I have the PR for the NUCLEO N6 DCMIPP. That's the digital camera interface. Okay, and then I also have the PR for the IMX219. So I have a device driver for the IMX219, and I have a device driver for the peripheral that the IMX219 is going to connect to. And I'm joining this together into this PR called the IMX219 UVC PR. It's not a PR, it's just a branch. And this branch should be accessible from my fork of Zephyr here. Copy, and I'll put this in the comments. It's already in the description. I think I should also add the two PRs, the driver, let me add this in the description as well. I'll add this in the description, code we're working on. So yeah, UVC, okay, cool. And then this is the branch, and then there's another one. There's this one, which is the IMX driver. And then there's this one, which is the DCMIPP driver. Actually, no, that's not the one. So because I'd like you to be able to access this so that we can actually move together. I'd like to just see this PR. I don't want to see the file itself. I'd like to just go, maybe even conversation. Yeah, that. So that. Okay, cool. So save that. Hopefully it doesn't kill the stream. Everything's good. OBS is running. And Zach has his usual hay fever. I discovered this. It really helps. It's a hay fever antihistamine. Story for another day. Okay, cool. So let's. I pull those two out. I pull those two out. Bartholomew is here. I pull those two out and I merge them into one branch that we are going to be using today. So that's the IMX219 UVC. However, it's not just that simple. It's not just as simple as bringing in the driver and then bringing in the driver for UVC and then bringing in the driver for DCMIPP and IMX219. It's not that simple, because the one thing we need to notice is that in the UVC sample, if we browse sources here, we'll see something. So this UVC sample, because it has the ability to use the software video generator here, all it does is just it activates a UVC device. That's all, and then you can use that. That's really all you need to do. All the drivers are done for you. Luckily enough, this is the awesome stuff about building on an operating system that's being actively developed, because you can use so many other people's code and so many other people can use your code and projects can go faster. So there's a requirement here that we need to fulfill. If a board is equipped with a supported image sensor configured as the Zephyr camera chosen node, then it will be used as a video source. I hope you can see where I'm going with that. So we've already done this thing. Where we've played video that is playing from the this video is coming from the software generator. So now what we want to actually do is do this part. Either board is equipped with an image sensor configured as the Zephyr camera. So the first thing I would like to do is to try and connect the IMX219 as a camera on this thing. And I think I have an idea of how to do that, chiefly because I've been experimenting with it and I got stuck yesterday, so I didn't want to get stuck today again. So here's the app overlay. And earlier I just removed the Zephyr camera chosen interface. All I need to do here is to just remove this. But this isn't all I added, to be all honest. So let's go through what I added. The first thing I did was I looked at this PR for the video driver. And this video driver PR has a test, an app overlay test over here. And the app overlay helps us learn how to add drivers. Well, not drivers, devices and configurations to our development board. So you have to make a clock, it seems like. And then after you make a clock, you need to point to your IMX219 and you need to point at it with the correct address. I happen to know that the IMX219 address is number 10. And this is because we use the IMX219 at work. So this board, the Tiny Clunks 33, this is an FPGA board with a soft-core processor. This is what I use at work daily. And this comes with, it can take 6 camera feeds, although this board itself has ability to get 2 camera feeds, because we have a little, I'll show you. We have a little daughter board. We have a little daughter board here, this daughter board. And what this does is it plugs into one of these ports. But what this can do is it can accept, and I'll show it to you here, it can accept 2 IMX cameras. I hope I'm doing that right. I shouldn't do this quickly. I'll show you. Okay, and I'll take another IMX camera. And I'll connect it. And look, we have this one, that's an IMX camera, and that's an IMX camera, and both of these can be plugged into the Tiny Clunks. I should do this carefully. This is expensive equipment. Amazing. There you go. So that's the Tiny Clunks running, Tiny Clunks 33 running 2 IMX219 cameras with a bridge. And actually, we have something called a dual MIPP to USB bridge. You can find more about this, or you can find more about that, if that's what interests you, at either Tiny Clunks, somewhere here. And this whole website should guide you. Excuse me. I don't know if Nathan's here. I was really hoping Hey Fever wouldn't show up in this stream. But this whole thing is a whole story to tell you that I am aware of the address for the 219 because I use it a lot in another context. So what I need to do is probably add an overlay that connects the camera. And then I need to add another overlay here that makes a clock for the camera. But it's not as simple as that. I'll take a breather. Any questions at this point so far? I'll take a breather before I go on, because it's just going to get really information dense right now, so I'm going to stop for a bit. Any questions so far? Anyone want to say hi? Anyone want to say this is scary stuff? I'm very scared about it, to be honest. No questions? We'll keep going. That's not exactly how video really works, because you have like a sync device. You have a sync device. I would like to disconnect something here so that it can be on power. It can be powered. That doesn't change anything. So this CSI connector over here, this blue CSI connector over here, it goes into a interface in the MCU that's called DCMI. DCMI is a camera, is a parallel camera interface. So here, let's go here. Let's get a reference manual. It's quite embarrassing that I do not have a reference manual of this DCM3296 already. I'll save it. I'll save it in my N6 folder. Yeah, NUCLEO N6 there. That's where I want it. So I only have a schematic there, but that's fine. That's fine. So cool. This is opening. This is saving. What I want to show you is there's a peripheral in here called DCMIPP. That sounds so weird to say. That just sounds so weird to say. And let me know if I need to zoom in and stuff. Bartholomew, that's your job. If I'm showing something that doesn't show correctly, Bartholomew has to tell me. If it doesn't show correctly, blame Bartholomew. It is Bartholomew's fault because he never told me. Okay, cool. Just online giving people jobs they don't want. Let's look for that driver. Actually, can I fix the lighting situation? Cool. That's okay. That's much better. So let's fix this now. So let's find out about. It has Oxy. It has Oxy. Yo, so cool. Such a cool device. Let's find that digital camera interface. Digital camera interface pixel pipeline. We know what DCMIPP means. Okay, so let's read that. Let's read that quickly so we understand what it is. The DCMIPP is the pixel pipeline section of a high-resolution camera subsystem. It gets pixels from a parallel or a CSI from a parallel. I don't know how to say that. So, how do I get this off again? Oh, that's the opposite side. So, that is a parallel interface. It probably has something like 22 pins, if I'm not wrong. I'm pretty sure it has 22 pins. Yeah, I'm pretty sure it has 22 pins. And basically, this camera has, if you've ever looked at the IMX219 pinout, IMX219 pin out. It has, if I'm not wrong, it has 24. I am. I just read a lot. I promise you, I'm not like some AI. It has 22 or 24 pins. I think it's 22. And 4 of them are like synchronization ones. And then there's like either 8 data lines or 16 data lines, or some can even have more than that. So let's look at it. It has a pinout. I remember the pinout is something like, I can show you this too. I can show you this on a different camera, but most DCMI or parallel camera, it's a parallel camera interface. I don't even know how I said that. Parallel camera interface. So I'll show you. I have something that can show it. Where's my OV? Either that or I have something else here. I should have a camera that shows this. Hang on with me, I am on the stream. Yeah, cool. Let's use this. So this is an Ardocam. This is an Ardocam. I think this is an OV5640. Well, I just want to show you the pinout. The pinout for that, the pinout for the IMX looks like that. So it's quite a few pins. This actually is quite less because this has only 8 data lines. Some of them can have up to 16 or even more data lines. It's in the It's in the, it is in the documentation. What's my point here? What point am I making? The camera has a very wide parallel interface, and this interface is connected to DCMI. DCMI on this device makes a pixel pipeline. So basically DCMI is not a thing you really use, you just use it as a pipe connector. You see? And this actually explains a lot, because there's on this DCMIPP branch, when you go to the files changed, you can see that this is called the overlay. The overlay, if we might be able to see that, view file. If we look at it here, it's called pipe, something like main pipe or something like that. This is an overlay. There should be pipe, not DCMI. This here, CSI capture port. Whoa. CSI capture port. What is it? Where is there? Where is that? This is not. Yeah. Wait. What? Where is this defined? Where is this defined? Oh no. Is this what I've been debugging all night? CSI capture port. Okay, cool. Okay, cool. Yeah, just show it to me. DCMIPP. That's fine. That's okay. We might have actually found a fix in some other branch, because there is a problem with our current branch. It kind of jumps forward, but okay, cool. Where's the DCMI capture port? Yeah, but where is the capture port actually created? I have a feeling it's in DCMI itself. Yeah. Control F, capture port. Yeah, where's the next one? Where's the next one? Capture port 1. CSI interface, DCMIPP. We need to go and look at the CSI interface on the port 1 capture port. I would like to look at the board's SD. Okay, cool. So let's actually go look at that. Boards NUCLEO N6 DTS 0Q DTS. Yeah, let's look at you. Okay, that's fine. Common DTS. That is actually what we're looking for. Yeah, common DTS. Okay. DCMI. So there's a CSI capture port here, and I've been using that. Okay, this might actually be simpler than we thought. UVC samples, UVC sample UVC app.overlay. Yes. I wonder if anyone could see the mistake. I might have been using the wrong port. I don't need to make you guys go through the error because anyways, let's actually just use it. Let's build it. Let's build it like this first. So what I'm trying to explain here is you actually need to what I'm trying to explain is how you build this interface. And now because I found the other bug, I found why I was going wrong. Because let's just use it actually. Because that actually just causes a hard fault, which is the one me and Bartholomew were trying to figure out last night. Let's actually see if this fixes it. So, and then we'll come back and revisit this whole overlay. I'm coming now. Does anyone have any questions? All of that running around must have been very confusing. So I'm sure a few people are lost, just as I am. I am right now. I am lost. And I think I need to explain this better. Is there a part I can explain better before I jump into other stuff? And I'm doing this partly for myself so that I calm down, and because I just realized the mistake I was making. Any questions from anyone online right now? No one. Okay, cool. So the thing we need to do in order to make UVC work, let's see if it works. The thing we need to do in order to make UVC work is we need to have a chosen, if a board is equipped with a supported image sensor configured as the Zephyr camera chosen node, then it will be used as the video source. So what we did here is we added a chosen node with a Zephyr camera, and we put in the CSI capture port. Okay. However, when we're using the IMX219, as we can tell from the IMX219 driver port, where is it? Drivers, IMX219, we need to add an input clock. And then whenever we define, wherever in, so I'll just open this file so we see it, view file. Let's see what the two things. So number one, we see an input clock is defined here. And then the next thing we see is on this I2C interface, we see a camera for the IMX219 is added. So let's find it, IMX219 here. So this actually uses a port, and the port actually connects out. So there's this concept of ports, and ports are like pipes from this thing to the other thing. So from I2C, which is the controlling interface. So the IMX219 comes with two interfaces. You have a data interface, which is a parallel line of something like 16 lines or 8 lines or 20 lines or however many lines, and then you have on the side of it you have an I2C interface. And I showed this just now. I won't jump into a different camera. So you have an I2C interface to configure and control the device, and then you also have a parallel port of 8 to 16 lines on the other side, or more than 16, maybe 24 even, on the other side, which actually enables you to now collect the data. Now, once you have this data, you need to connect this parallel port into DCMI, because DCMI expects you to define a port and give them to it. I had something open now. Let me try and open it again. Documents, NUCLEO N6, which I just closed. Where's the reference manual? This is it. And hopefully just open straight at DCMI, and we don't have to spend time looking for it. Digital camera interface pixel pipeline. That's the PP. That's why it's called PP. Give me this, and I just open this wide a bit so that I can actually see what I'm looking for. And I'm looking for the digital camera interface with general pops. No. There's a GPU in here. Protect me, people. I could very easily get distracted. So this, yeah, 8-bit, 8, 10, 12, or 14 parallel interface. Okay, so what this expects is for you to pipe some data into it, but it doesn't do configuration. So you have to, when you need to tell the camera the pixel format it needs to use, how big your screen is, how all of these things are. When you need to do that, you need to when you need to tell your camera that, you need to use I2C. However, to collect the data itself, you need to use one of these pipes, one of this 8, 10, 11, 14 bits. And as you can see, it has a parallel interface. It has an embedded or external line or frame synchronization. It has a continuous or snapshot mode, crop feature, and supports this video formats. However, we don't see a format for changing those things. Okay, the format for changing those things, especially for this thing, is going to be via I2C. I would need to jump into the IMX219 datasheet. Do it, because that's what people are here for. So IMX219 datasheet. Yeah, hardware connection. I like this one. Oh, IMX219 data sheet. Hella confusing. Yeah, we can put it in there if we want. Yeah, sure. Please be the datasheet. So this is going to be a datasheet for IMX219. Yes, it is from Sony. Yes, perfect. And it will tell you it has an I2 2-wire serial communication interface on chip. This is for configuration. And then it will have a CSI2 serial data output of selection of either 4-lane or 2-lane. So however many lanes you have. Okay. So those two, you use I2C to configure the device, and then you use the parallel interface to fetch the video. I think this might actually just go completely straight and work right now, because I had a bug and then we just found where the bug was coming from, and we're just gonna try and build it and see. If we have a bug, then we start digging again, and that's okay. I'm gonna build now. Does anyone have any questions? Bartholomew, I know you have a question. Just ask it. I always put Bartholomew on the spot. When I don't stream, Bartholomew is very upset. No, I like that. That means he's my friend, so I'm okay with that. Any questions? This build is gonna take a minute. Hopefully it actually builds to the end. Which might actually just go like, it's working. And then I spent like a night debugging hardware faults and hard faults, and I don't need, Bartholomew doesn't have hard to check it out. STM Microelectronics. There is a dude in Poland. His name is Bartholomew. He does not have the hardware to check out your N6 running UVC. Please send it to him. If you need his address, ask me, and I can show you his Discord account, and he can get it. Is that right, Bartholomew? He doesn't have hardware to check it out. I'm not making fun of him. It took me quite a while to get this hardware, and I didn't even get it. It was bought for me by Joshua from Panoramics Labs. Joshua from Panoramics Labs. Let's do some ads for some video sponsors. Yes, Bartholomew says I am right. So Joshua from Panoramics Labs. Why Panoramics Labs. Yeah, Joshua from Panoramics Labs, who does this. Actually, get in touch with him if you have this work done, if you need this sort of stuff done. Yeah. if you need this sort of stuff done, Joshua from Panoramics Labs does this very well. Please get in touch with him, Joshua. That's his address. That's his. You can use those things to talk to him, and he can do small independent laboratory specialized in the hardware-software interface, hardware description language, FPGAs, ASICs, firmware, and driver. Not afraid of extending to surrounding domains as needed, manufacturing process, system software, RTOS, analog circuits, and RF signals. Joshua's your man for this. Talk to him. Or talk to me, and then I'll kind of talk to him, and then whatever, however way you want to reach him. Cool. So let's put this thing in bootloader mode, like the NRF52. West flash. Oh, no. Can't do that. West flash. So it's in bootloader mode, and the way you know that is that cable is right. And I'll remove the USB part so that if it does actually work out, it pauses at that point where it goes like it wants to see you ask for video. And then I'm going to put the pin, boot pins correct again, and I'm going to reboot, and I'm going to come here. It works. It works. Bartholomew, there was no hard fault. It works. I think it works. Let's actually see if it works. ls dev video. Sorry, I went offline. Sorry. Bartholomew, am I back? I've just discovered what actually happens is that whenever I use FF Play to play a video, this is actually what happens. Whenever I use FF Play to play a video, it crashes. It crashes OBS. that's why the stream keeps failing, because every time I play video, it goes and crashes. Okay, cool. So let me see if there's another way we can test this, but it works. We get video. It works. Let's actually see. Is there any other way we can test this? Yeah, be here. If I use VLC, can I open media, open network stream, choose a capture device, capture mode. What's here? Okay, cool. Can I do this? I'm back. Okay, so I can't really use USB video, because if I use USB video, I crash my webcam, which is also using USB video. And that's a problem. Which means I need to build like a Pi for streaming or something of the sort. I need to build a different machine for streaming. So the thing is, it works. It actually does work. What we can't try is try and use the capture sample. Perhaps we can try and use the capture sample. Let's see if we can try and use the capture sample and actually run it. cd Zephyr samples drivers video capture. Yeah, let's do that, and then I can do cut read me, so you can see this is just if we can see this, it means we got frames basically. Yeah, So CP, actually I already actually even tried with this. So there's an app overlay here, and I think we realize we can say CSI interface. What did we say it was? CSI capture port. That's what we called it. So let's do that. CSI capture port. So yeah, that's okay, that's fine. Let's actually, where am I here? Oh yeah, I shouldn't be here, So, cd project, cool. And then I need to go back and do that, but I don't want to build a I don't want to build this UVC sample, rather I want to build a driver sample, the video sample, and the capture sample. Okay, let's build that. If we, what I want to see, what I want to see is that we get these logs from, the thing, Zephyr video sample. What I'd like to see is that we get this, yeah, video capture, yeah, to TCP sync, What can I do on the other side? So I just need that. Then from up here on the same network, you can connect and grab from TCP client source host. It goes 192.0.0 port. Can I figure this one out quickly? TCP client source host equals to 192.0.2.1, but I do need to probably, can I figure that out? Can I figure that out quickly? Let's see this build and we can build capture logs. Still building. It's really build, so can I figure out how to do that? Do I need to set? I need to probably set quite a bit. Which Wi-Fi? Look who we found here. Anyways, look who we found here. So we probably need to say IP address, my IP address, cool, config net, that's fine. But I do need to, how do I set the Wi-Fi? Is it in the, how do I set the Wi-Fi? Yeah, but I can't reach you. You need to be on my Wi-Fi so I can get to you. How do you know which Wi-Fi to go on? Yeah, we're on the README. Sorry. I'm shouting at my brain. How do I get you to choose a Wi-Fi place? Okay, that's built. This is the capture sample. Either that, or I'm gonna have to record a video offline and then kind of like upload it later. I can't do streaming and my webcam at the same time. So that's been connected, and then I'm gonna do this, and then I'm gonna put this guy, and I'm gonna reset the board twice, and then let's come back here. This is okay. This is fine. We can see a video device. We can see the capabilities. We can see the height, the fault. This is fine. This works. So there's a video device there. We can just, we just can't use it. I wish I knew how to get TCP sync working, because then we would have just connected, or I would have gotten a device connected and then we could have just used yeah, that's fine. Yeah. Default format, and that's all. That's it. So it doesn't want to start because video help. So it wants me to do video dash help. Okay, cool. Video. Okay, video. Just if I do video. 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 Start. Video command not found. Devices not found. But look, HDMI pixel format is failing. Okay, cool. And we're in DCMIPP, so it's fine. DCMI, digital camera interface pixel pipeline. I know what PP means now. Amazing. Let me think about it. So, people, everyone on the stream, I have to actually go figure out a way to make the TCP sync work. That way I can start video on the device and then send it to... Doesn't work. You know why it doesn't work? It's not that simple, because this needs Wi-Fi, or it either needs... I need to like use a cable and connect it to... Yeah, because we need internet. That's a problem. That is a problem. Cool. Can I maybe stream from my phone? Can I stream from my phone? No. Can I stream from my phone? Okay, cool. Here's the situation. I can stream without the webcam, can't I? I can stream without the webcam. We don't need that source. Let's see. Let's see if we can. Let's see. Can I do that? I'm trying to see if I can actually change the integrated camera. Can I use this pass USB device, video index 1? Let's actually see. Can I that? Okay. No. So what I'm trying to do is try and use UVC. I'm trying to use UVC, but I'm trying to make it so that I can use the... Okay. No, it doesn't. It doesn't do that, so just integrate camera. Okay, cool. Okay, let's see if I can just do that. Cancel. Let's add a scene, add video capture, video capture device, audio capture, screen capture, video capture. Yeah. Okay. And then this will go from, yeah. Okay. No. Oh. Oh, I'm running the wrong running the wrong project to get that. Yeah, hold on for me. We just might be able to make this work if I'm clever enough. I'm usually not. Cool. So I want to delete this. Remove. Yes. Okay, cool. So what I'm trying to do is I'm trying to kill my video, the video that's coming to my screen. I want to not use that webcam, and I would like to use the camera on the NUCLEO device as UVC, because anytime I try running both the stream and the UVC sample using FF Play, we end up not getting a source. So we'll just get this working quickly. I'm just gonna rebuild the UVC sample and reflash the UVC sample, and hopefully we can get UVC to stream over OBS to you guys from this. That's still already cool for me. That's really cool that I can stream from my microcontroller to OBS and then OBS to you guys or you people. When I say guys, I mean guys from me is a gender neutral term. I'm not by any way implying that there's that girls are not here. I'm sure there's some girls here, and I'm pretty sure I really appreciate having them, and please don't be shy. It's not just about guys. Okay, cool. So let me reflash that, the UVC sample. I'm going to put it in bootloader mode, and then we're going to do west flash. Cool. So sorry, I'm back. It appears that I cannot have two UVC things going on. I cannot have my UVC camera going on with OBS collecting UVC USB video from my USB webcam, which is all webcams, virtually all webcams use a UVC chip right now. They're just like straight to hardware, they use a UVC chip. So basically what is happening right now is I cannot run OBS and UVC at the same time. So I'll have to do something like record a video and then I'll upload it. In the meanwhile, does anyone have any questions on what we've just done and how it's gone and what we need to do? Even if you're asking really basic questions, that's why these streams exist. Just ask me whatever. Is it confusing what I just did? Is it straightforward what I just did? Was it helpful what I just did? I can see there's still quite a few people on the stream. Please do answer me if you can. Yeah, Bartholomew, you're the first one. Reviews, please. Was it confusing? Was it helpful? Is it fun? Encourage people, Bartholomew. Anyway, I need to know, was this, because I'm going to have to specify the type of camera module. I am using the Raspberry Pi V2 camera. Raspberry Pi V2 camera. I'll show you. I am using the Raspberry Pi V2 camera. RPI V2 camera. It's an IMX219. It's here. It's here. Show you. This is the camera I'm using. Sony IMX219. How do I have connected to the how do I have it connected to the NUCLEO? I'm gonna show you now, Bartholomew. There's a CSI connector on the NUCLEO. I think CSI is something like camera serial interface or something like that, or camera interface. But there's a CSI connector on the NUCLEO. Let's actually look at it. Hey Monty, it's fine. You can be confused. Being confused is the beginning of not being confused. So it has a CSI connector. The STM32 has a CSI. I can show you. It's easier this way. Hang on, Bartholomew. So the STM32 has a CSI connector that takes the camera, and it also goes to I2C2, and that's where I've connected it to, using a CSI cable. This is a CSI cable, basically, and it goes into like a 22 pin, either 22, 12. There's many connections, but this one has a 22 pin, and I can try and actually find. I can try and find a picture of the board. NUCLEO. Yes, correct. I2C is only responsible for the imager configuration. So I don't know if you can see my screen right now. There's this little connector here. This is a CSI connector, this one here. This little connector is what the camera is connected into. This is a CSI connector. It's basically the same as the Raspberry Pi connector thing. Monty, what are you confused about right now, if I may ask? Is there any one thing I can help you clear out that makes it easier to start thinking about these things, Monty? Welcome, Monty, by the way. Bartholomew, I'm waiting for the next question as well. I2C is used for configuration, and then we use DCMIPP, DCMI pixel pipeline for collecting the frames themselves. Any more questions? Cool. I want to use this because now I have an imaging project going on, yeah? What I want to do is go back and use it here. You remember I spoke about libmpix the other day. And recently, libmpix had a new thing. We had a new merge into libmpix. I'll show you just now. Let's see the comments. DCMI libmpix had this ARM helium. We had helium SIMD accelerations added into libmpix, and libmpix is a microcontroller. It's software for a microcontroller that helps you do image signal processing. So you can get raw image data on the other side, and on the inside you end up with an image, a JPEG, a PNG, a video, all of those things. You need to do quite a lot to data, raw data, because remember, raw data just comes to you like a buffer. There's maybe like 800 by 600 pixel buffer. Each pixel is maybe something like 4 bytes, and then you get it as a buffer, and then you have to go like every 800 is a line, and then you have to take all of those lines. You have to do this Bayer filter wiki. This. You have to do this process, Bartholomew. You have to do this process. You get raw data, you get light data, which is data from ADC. No. Well, no, yes. I don't think you can run OpenCV or STM32. I don't think you can, unless there's some sort of MicroPython port for STM32, and then you can use it that way. But now you're asking the right questions. If you think about what OpenCV can do, libmpix is very tools for doing OpenCV typing work. Yeah, Monty, the easiest way to get used to this level of hardware programming and debugging is to just start something and do it, to be honest. Don't be scared. Like, do something that you're scared you won't know how to do. That's the easiest way. As you try, you will find out you can. But if you don't try and you look at it and you think you need to learn everything before you can do it, it's going to be very difficult. But when you start trying and you just keep on trying, you find these little things. Suddenly things become more familiar and more familiar and more familiar, and then you can kind of get there. So Bartholomew, I don't know if you can run OpenCV on STM32, or maybe you can run it on the STM32 also makes like A-class devices, which is like microprocessor devices. Then you can definitely run it. Bartholomew, that's the whole thing. Once you can process the image, you can do anything with it. I can't exactly say right now because that's a work thing. There's an NDA that prevents me from telling you what I want to do, but I can tell you I'm doing it. I can tell you I'm processing images. You can do any of those. So which one do you want to do, Bartholomew? Do you want to do face detection, license plate detection? What do you want to do? I would like to make like to make some sort of very basic image classifier, like the one on deep neural networks and deep learning, neural networks, because this thing has a GPU on it. This thing has a GPU on it, and we can use that GPU to do stuff. So I wouldn't mind making this, using neural networks to recognize, like you want to recognize this is 504192. You want the microcontroller to do that. But all of this is like stuff you can do. This is just the base. And then on top of that, what are you going to do? Once you can detect faces, then what? Once you can detect license plates, then what? Which is already actually being done very widely. How are you going to use that's a recipe. How does that become a meal? How do you sell that? How does that become a product? That's a question. Once you can process the image, you want to do something with it, but everything starts with you processing the image. So it really, I don't know how to say it. It's like, what will we do with it? What will we do with it? That's the question. Any other questions? I'm gonna stop the stream at some point, and then I will record the video of UVC working, and I will send it out to you guys. But in the meanwhile, we can ask questions. Any more questions? I'd like to answer them. I would really like to answer the questions. No, thanks. Okay, cool. Any more questions? Any more questions? No questions? Monty, any more questions? I'm going to give Monty a chance to ask some questions. Don't be shy. Whatever you're asking today is important. Just ask. I'm going to give Monty a chance to ask the questions, and then we're going to finish this soon. No questions? None so far? Okay. Anyways, this has been one of like the better streams. We had 32 people show up to this stream. although it's only Monty and Bartholomew that ask questions. I'm very sorry about the couple of drops, and that's actually what happened yesterday in yesterday's stream, because I didn't realize that whenever I would run USB video, it just kills everything. So I think tomorrow, I don't even know what we're gonna do tomorrow, to be honest. We're either back to the audio project, and I'm still considering whether I will do 2 streams a day, but or not. Sometimes they're sustainable, sometimes they're not sustainable, and then I end up being busy on other things. But then sometimes they bring up problems that I need to discover for other things, and that's a good thing. However, thank you all so much for showing up. This has been a fun one. We've discovered stuff, and because I started actually streaming, I found the bug that had been bugging me, because Bartholomew can tell you I have been hunting hard fault since yesterday, but it wasn't a real hard fault, because this is what I was doing. This line was wrong. I was supposed to be using the CSI capture port. Other than that, thank you all so much for showing up today. This has been an amazing one. See you tomorrow. We'll do more awesome stuff and get low power, little computers doing high power stuff. Cheers. See you guys. Amazing. See you people. Yeah, I should remember that. Okay, cheers everyone. See you. Thank you, Monty. Thank you, Bartholomew. Thank you everyone else who came through.